Hello and welcome to today's ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of nearly 100,000 computing professionals and students. I'm Bart Knijnenburg. I'm an assistant professor in human-centered computing at the Clemson University School of Computing, where I co-direct the Humans and Technology Lab. My research is in privacy decision-making and user-centric evaluation of adaptive systems. I'm also an ACM member. For more information on my background, check out the bio widget on your screen. For those of you who may be unfamiliar with ACM or what it has to offer, here's some more information for you. The ACM offers educational and professional development resources that bolster the skills and enhance career opportunities of our members. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources available at learning.acm.org. You can see some of the highlights that are offered there on your screen right now. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in the global environment. The ACM provides timely computing information published by the ACM, including the communications of the ACM and Q magazines. Access to the ACM Digital Library, the world's most comprehensive database in computing literature. International conferences that draw leading experts on a broad spectrum of computing topics. Support for education and research, including curriculum development, teacher training, and the ACM Turing and ACM Prize in Computing Awards. And the updated ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. The ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Now, before we get started, I'd like to make a few housekeeping announcements. They're shown on the slide in front of you right now. So first of all, the slides will advance automatically throughout the event. And so on the bottom panel, you will find some additional widgets and resources that you can use. If you are experiencing troubles with the slides or with the audio, please press the F5 keys on Windows or Command R if you're on a Mac, or refresh your browser if you're on a mobile device. Or if that doesn't work, you can try and close and relaunch the presentation. Volume control is just the master volume on your computer. If you have questions during the talk, please type them into the Q&A box at any time and click the submit button. I will organize the questions as Joe speaks. He'll reserve time at the end of the presentation to address them. This session is being recorded and will be archived, and you will receive an automatic email notification when it becomes available. And you can also check out learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill this out to improve our tech talks. You may also open the link to the survey at any time from the resources window on your screen. You can use the Facebook and Twitter widget on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag ACMLearning. We'll be watching for your tweets. We also have a community discourse page to continue the conversation after this webcast. And that's also where you can ask questions that we won't be able to get to during the Q&A of this session. Today's presentation is Recommender Systems Beyond Machine Learning by Joseph Konstan. Joseph A. Konstan is Distinguished McKnight University Professor and Distinguished University Teaching Professor in the Department of Computer Science and Engineering at the University of Minnesota, where he also serves as an Associate Dean for Research in the College of Science and Engineering. His research addresses a variety of human-computer interaction issues, including personalization, particularly through recommender systems, eliciting online participation, and designing computing systems to improve public health. He is probably best known for his work in collaborative filtering recommenders, the GroupLens project more specifically, which won the ACM Software Systems Award, and the Seoul Test of Time Award. Dr. Konstan received his PhD from the University of California, Berkeley in 1993. He's a fellow of the ACM, the IEEE, and the AAAS, and he's a member of the Chi Academy. As an active ACM member and volunteer, he is co-chair of the ACM Publications Board, served as president of ACM SIGCHI, and is a member of the ACM Council. Now, Joe, without further ado, please take it away.
Thank you so much, Bart. And I didn't know somebody could use the phrase ACM that many times in one introduction, but I'm very proud to have those associations. So in this talk today, I'm going to start with an introduction so that those of you who don't have a deep familiarity with recommender systems can catch up. And then we're going to plow ahead and talk about where today's technologies for recommender systems may not be getting us what we want and what we have to look for towards the future. When I talk about a recommender system, I'm talking about a system that helps typically a user, but in some cases a marketer or salesperson, narrow an otherwise overwhelming set of choices. So what are examples of these kinds of recommender systems? We're probably most familiar with sites like Amazon.com, where there's lots of products it could list to me, and it's going to make a recommendation by putting out some products on screen that it thinks I would be interested in. Another example of that might be Netflix, where it's recommending a set of movies I might like. But we also have recommender systems that work as filters. For instance, inside our email, I now have, in my case, Gmail, which filters my email into different categories based on how much it thinks it's something I want to pay careful attention to, maybe a little attention to, and just delete, this is probably spam. We also see recommender systems that predict values as to how much you will like something. And those we commonly see in spaces where we're reviewing products. So stars for hotels or restaurants. We see similar things showing up with movies, or even with consumer products where we now see stars associated with them. So a recommender system could come in many flavors. We have systems that are generic. Everybody receives the same recommendations. So if I want to recommend music to listen to, I could go and find the Billboard Top 100 and say, here are 100 songs that people say are worth listening to, or anything else that everybody gets the same. Those are not interesting for what we're talking about today. We're going to move towards personalization. And the first type of personalization people sometimes do is categoric or demographic. Gee, you're a male in a particular zip code. I'm going to recommend this to you, and I'll recommend something else to somebody who's female in a different postal zone. You can do this. Technologically, they're not all that interesting, and most of us don't really want to be defined by sex, gender, income, zip code. And so we'd like something that's a little bit deeper. And so we then get to an ephemeral or short-lived personalization. So when you're browsing through a site, even if it doesn't know who you are, it can track the things you click on and match what it recommends to you based on what you've been clicking on. You go to Amazon to search for an LED light bulb, and it starts showing you other LED light bulbs. Then you look at a battery pack, and it starts to realize, oh, maybe you're interested in electrical and lighting, and it can recommend things like that. But the area we're going to spend our time on today is persistent personalization, building a profile of what you like and matching what we try to present to you to your entire profile. And I should say that just as there are many different types, there are many different approaches to recommendation. They start at the really simple manual level, right? You go to a restaurant and the chef says, gee, the fish came in on Tuesday, now it's next Tuesday. If we don't sell the fish today, we're going to have to throw it out. Everybody recommend the fish. It's not the kind of recommendation we really want to talk about today. But you can then move towards using other people's data in simple summary statistics. You go to TripAdvisor, you look up a hotel, it says, gee, the average score for this is 4.3 stars. That's not personalized, but it can be very useful. You can do product associations, what two things sell together often. This works really well in certain circumstances. If you're, somebody has a market basket filled and you notice that they have hot dogs and buns, and you say, wait a minute, a lot of people buy mustard or relish right now, and we can suggest that right before you check out. Those product associations can be useful. And then we have techniques that are content-based, that learn from a user's profile of what kinds of things they like. You go through all the movies I've watched, and you say, wow, you seem to like movies that have certain attributes. They are short, they're characterized as happy, they have comedians as actors or actresses. I could find more like that for you. And the technique we're going to spend the most time talking about today are collaborative techniques, where we learn from other people's profiles as well as your own. And as we talk about machine learning, the one constant in the field is, if there's a way of putting data in, whether it's manual data or aggregate data or content data or ratings data, our machine learning techniques are going to use all of that. And that's indeed what's happening with today's state of the art in machine learning. So I'm going to take one more round of just understanding the intuition behind these recommenders by taking you through two of the very classic algorithms in about 75 seconds each. If you imagine this is a table where I've listed my opinion and other people's opinions of a bunch of movies, one way I could decide which of these movies on the top right, Blimp or Rocky 15, I might like best would be to say, hey, who are some people who more or less agree with me or maybe even consistently disagree with me? And then take those people's opinions. Once in a while, I'll get somebody who agrees with me and doesn't have an opinion. Can't use Pat here. But take those people's opinions and say, wow, gee, Nathan likes this. Nathan agrees with me. John and I disagree consistently. This seems like it's a good movie. The only data I have on Rocky 15 is that the one person who also liked Star Wars and didn't like Hoop Dreams didn't think it was good. So I'd probably go see Blimp tonight. That's sort of a basic idea, what we call user-user relationships or user-user collaborative filtering. Now, I could take that same matrix, that same idea, and use it backwards. So I could come here and say, hey, I'm interested in Blimp. Well, Blimp was rated by a whole bunch of other people. What is Blimp most like in our database? And we'll see that Star Wars and Blimp have a similar pattern. And, interesting, Pretty Woman and Blimp have a similar pattern. And if I aggregate that, I can see, wow, those are two movies I sort of liked, so I'll probably like this. And I could do the same thing with Rocky 15, where I discover, yeah, it's also like Pretty Woman, but it's also a lot like Hoop Dreams. Yeah, B to D, I probably won't like it as much. And the fact that you could take the data one direction or the other is actually a pretty important point. And then the message it's saying is the relationship between products is about people, and the relationship between people is about products. When you realize those are the same relationship, it opens up lots of other ways to go through things. And so, today's solutions have evolved. We have this lovely matrix that we may think of as a starting point. And one thing we can do with that matrix is turn it into a latent factor model. Not going to go into the math here. That belongs in another place. If you really want to go through this, we actually have an online course on recommender systems where you're welcome to do this. But if I approximately factor this matrix using a technique known as singular value decomposition, I can compress it and say my opinion is actually based on some number of relevant attributes of how people like movies. And the movies can be described in the same attributes of how people like movies. And once I've done that, two things become possible. One is I can almost instantly tell how much I'm going to like any movie by just matching my vector of how much I like the attributes with the movie's vector of how much it expresses those attributes. You know, for those of you who want to do this with math, it's basically a dot product if you represent it properly. And that's a really easy thing to do. But even more important, I can skip all of the factoring the matrices. And I can say, oh, if my goal is to learn a set of factors that do a really good job predicting what movies people would like, I can do that directly with optimization techniques and say, well, I'm going to sort of randomly set up a set of factors, and one by one, I'm going to tune those factors by seeing how wrong they are and moving in the direction that makes them right. And then tune the next factor and the next factor until I have enough factors that I'm doing a pretty good job modeling everybody's opinions in this database. And then we'll use those to help predict what people will like from the other items in there. Now, those are the latent factor approaches. Those are actually the single most popular approach probably today in commercial recommender systems, but they're not the end of the line, because people who work in machine learning have realized that there's all sorts of other interesting models you can do with this, many of which add additional dimensions of, wait a minute, I have attributes of people like those demographics, or I have attributes of products like the cast and descriptions. And so you can go further. You can learn models using deep networks, these neural networks. We feed all the data in, we program them to optimize for what we already know to be correctly discovered results. And they actually do a pretty good job in this space. But people also have online learning systems. Some of the more popular ones that are working well today are systems that use reinforcement learning and systems that use multi-armed bandit approaches that say, as we're running a recommender system in real time, we'll make decisions about exactly what algorithm, what products to present to you, to balance how much am I trying to learn more about what you like and how much am I trying to fulfill what you would like in the middle of our interactions. And with those, you can, in theory, optimize for things beyond liking. You can optimize for, does it bring a customer back next time? How much do they buy over the next 6 months? And other things that might be useful if you track those things. So I'm going to pause here for a second and say technology's wonderful. I love computing. That's why I went into computer science. Yet, all too often, despite this wonderful technology, we end up with results that are somewhat less than desirable. So I come here and I show up at Amazon and it says, here's a bunch of stuff we're recommending to you. And, well, a large fraction of what Amazon is using all of this really powerful machine learning for is to tell me, hey, don't you want to buy again what you just bought? If you look at all of these panes of things, 5 out of the 8 of them are, why don't you buy it again? Why? Not that I don't want to buy it again. Sometimes I do. But I can really promise them that if I run out of chocolate sprinkles or sweetener or aftershave lotion, I know I need it, and I know I could buy it again at Amazon. I don't need a recommendation for that. I need a recommendation to find something I don't know about already. Or I could go to YouTube, and I'm watching an interesting video on Taiwan's Noodle Mountain, and it's saying, here are a whole bunch of other videos we would like you to watch next. Oh, every single one of these is really close. It's more food. Taiwan's most famous night market. Can you dry age a $1 steak? You can keep going. These are all food videos. Now, you don't know me. Maybe all I know is I never watch anything but food videos, but I know that YouTube doesn't think that, because If I go out and have it say, show me things I might like in general, there's comedy there, there's travel, there's all sorts of things. But somehow it made a decision algorithmically, no, let's just show him food video after food video till he gets sick of them. Why? But I can see this. This is my own system. It's a system called MovieLens. Now, you don't see what's wrong with this recommendation. In fact, these are perfectly reasonable movies. Except these perfectly reasonable movies have been showing up time after time when I show up. We're going to talk about that example later. And there's all sorts of other things like this. LL Bean did the same thing. It showed me a bunch of shirts and a jacket. It calls it a sweater. I don't think that's a sweater, but okay. And I went away not finding anything I wanted, and I came back and it said, oh, I've got a great idea. How about the shirts and the sweater we showed you last time? So there's something about these systems that are making recommendations that, as a consumer, I find not useful. What does that mean? What is useful? Is it accuracy? If all I cared about was accuracy, then in the US, every time you go into the supermarket, I would say, hey, I've got a great idea. Why don't you buy bananas or bread? And I would check when you left, and 70, 85% of the time, you will have bought bananas and bread, and I would say, what a great recommendation. But Bart would be at the supermarket across town, and he wouldn't say anything. And 70, 85% of the time, people would buy bananas and bread without the recommendation. And he'd say, I'm even better. I didn't have to lift a finger, and they bought bananas and bread. So just being accurate might not be enough because it doesn't make it useful. Maybe it needs to be novel, something you wouldn't have found anyway. Maybe you want diversity, not in every case. Sometimes you're looking for a light bulb, you want a bunch of light bulbs. If I went and I said, I'm looking for an LED light bulb, and it said, cool idea, but how about inflatable balloons in a helium tank? I'd say very artistic, but probably too diverse for me. But sometimes you do want diversity. Sometimes you want a feeling of personalization, that the thing it's suggesting to you isn't what it would suggest to everyone. You've probably had this feeling at a hotel where you go down and you say, I'm looking for a place to eat, and they immediately recommend, often the place in the lobby, thinking, no, I'm looking for a place to eat for me, not a place to eat that's where you send everybody. You need to learn a little bit about me for a recommendation to feel like it's personal. It might be about explainability. This is really important in certain spaces. Think about medical applications. It's not good enough to simply say, oh, surgery, I think that's what you should do. The coefficient is 0.6. You want to explain why. Why is it that we believe surgery is a good choice for you? Or why is it that we believe that this television set is the right one for you when it costs so much money? And of course, we care about usefulness and business value. Don't recommend things you don't have. Don't recommend things you're not looking to sell. No business succeeds for long if it directs people towards the lowest profit items, unless that lowest profit is pretty high up there. So there's a lot of ways of measuring usefulness. So I'm now going to take this through metrics and into what we might do about them. And to do that, we're going to start with just a little bit of metrics history and recommender systems, because that history started with a great schism. The field of recommender systems has evolved in parallel between researchers and businesses. And if you go back to the mid-1990s, researchers were thinking of themselves as doing what we called data mining or AI. Today we would call it machine learning or data science. And they thought about measures in the same terms that an AI, artificial intelligence researcher would. They would say, I know, I'm going to measure error. I'm going to have a bunch of data, all of which was given to me. I'm going to cover some of it up. I'll train myself on the rest of it. And I'll see how often I'm right or wrong, or how much I'm right or wrong with the data I hid. And the first sets of measures that were out there were measures of the mean error, the mean absolute or squared or root mean squared error, all of which said if I'm predicting on a 5-star scale and somebody actually gave this 4 stars, but I thought it was 3 stars, then my system had an error of 1 star. Conveniently picked so that the absolute squared and root squared are the same. But 2 stars is a lot worse off. And the squared errors were there to say big mistakes are a lot more painful than small mistakes. People did other statistical measures. What's the correlation between what we predict and what you actually rated? How often are we wrong, where we define wrong as off by more than a certain amount? And then later looked at things like how much do the top items that we recommend perform? Maybe I don't care if I can accurately predict how much you hate something, as long as I can accurately predict the things you're going to like the best. And so people came up with some measures about things like how many of the top some odd things that I recommended, usually how many of those were things that I'd already liked. And as researchers, what we looked for were statistically significant improvements, because we wanted to publish. At the same time, businesses came back and said, we don't care about this at all. I know this because I was starting a company that was trying to commercialize systems and sell them to businesses. They said, we don't care about your error numbers. We want to know what percentage of the things that we recommend people are going to click through or buy, or what percentage increase in dollar sales is going to result from using your recommender. The most common thing we were asked to do as a business in that time was to set up a test to demonstrate for the company how much more money will we make if we use your recommender instead of the one that we're already using, because we're not starting with random. That's something researchers do. We're starting with a really carefully built system from our own experts. And they had their own measures, lift being a measure of how much more we sell. They cared about things like customer return and retention rates. They cared about the time people spend on site. They care about bringing people back faster. All of those being interesting things businesses care about. Now, there are some challenges when you think about usefulness, because some of the things we care about only work in certain times. So diversity and accuracy tend to be trade-offs. If we know you like a lot of Star Wars movies, recommending a lot of Star Wars movies is the best way to be sure I'm right. But it's not very diverse. When I mix in other things, it's less likely to be as correct. But we've shown experimentally it can be more useful. People actually choose the list that's more diverse, even though they'll tell you the individual items on it don't average out to be as good. Novelty is not always good. If I came to a movie recommender and it recommended 10 movies I've never heard of, I can't tell if it's any good. I need things there I've heard of that I can evaluate. And as I grow to trust it, maybe I want some novelty beyond that, and I'm willing to trust suggestions people come up with. It's no different than if you went to a travel agent who was planning a vacation for you. And, you know, if the first thing they came back with was a place you had never heard of in central Uzbekistan, your reaction might be, huh? But if after 3 or 4 or 5 vacations that you found out they did a good job, they said, hey, I'm ready to let you in on a secret. There's this wonderful Uzbek resort you should go to. You might be ready to do that. Should also point out personalization can be a trade-off with accuracy. Things that are popular because lots of people want them. If you only show stuff that's not popular, you're probably missing out on some of the best stuff. And frankly, explainability is hard. It's technically hard, and it's hard to explain things in terms customers can understand, and there's a lot of work in trying to do that better. So we have some challenges here. Just a couple more thoughts, and then we're going to move to examples. I do want to remind you, marketing, and that's what recommenders are. We don't like the word because we think of ourselves as computer scientists, but we're computer scientists building tools to help in marketing, maybe help in self-empowered consumers too. Marketing's not a once is enough situation. Most of the time that you show a product, people don't take that product the first time. You know, there's different rules of thumb out there. Some of them say if you want a product, if you're advertising, you need someone to see the ads for that product about 7 times to be confident that they will consume it if they're going to at all. We see this. Television ads repeat all the time. Web apps repeat all the time. Amazon might not always be wrong to show me stuff I've already been shopping for. But users don't like feeling nagged. They don't want to feel like somebody's stalking them all over the web saying, hey, you didn't buy this. Are you sure you don't want it? Yet they need to be reminded of it at strategic times so that they really don't forget. And that involves some subtlety. And we should also point out that the goal is usually not simply to complete the sale. That might work with car sales sometimes, but most of the time you want customers to engage in a long-term relationship where they're going to have multiple purchases. And that will eventually lead to sales, and it may also eventually lead to referral business. But how you do that deeper relationship is often different from what you could sell and then have the person disappear. So back to this concept of metrics, the challenge that I want to take on is how do we translate user experience into something quantitative that all these experts who not only factor matrices, you know, in their head, but build deep networks and build multi-armed bandits and reinforcement learners can optimize systems for. Because today these systems are often optimized for the wrong thing. Come back to that point in a second. And we could do this different ways. There's a lot of middle ground. Sometimes you just have a hunch and you experiment. You say, why don't we try this metric and see what happens and whether, you know, sales improves if we try something that optimizes for diversity. I have no theory, I just think it's good. Other times we have theories that come out of the people who study choice and decision making, people who study consumer behavior, or that we build through a research agenda using psychology and marketing science. And we attempt to use those theories to build these metrics and experiment with them, because those theories might help us. And a simple example of that is work a number of people have done contributions to. One of them, the colleague of mine, Martijn Willemsen in the Netherlands, who's looked at this concept of choice overload. Psychologists have studied this for a long time. And when they look at that, all you need to know is if you give people a certain number of choices or many more choices, in certain cases, they're more likely to actually buy a product with fewer. There are classic studies for things like jams in a supermarket, but there have been other studies that if you have too many alternatives, your brain sort of freezes and says, I can't tell which one's any better, I just won't get anything. Well, with just that intuition, you can start building experiments and say, well, how many? How different do they have to be for them not to be overloading anymore? Is it good to have 2 or 3 that overlap, but not 7, or 5 or 6, but not 12? Can I have 20 products as long as they come in clusters of 2s or 3s that overlap, but the other ones don't relate so much? And before long, you have metrics you might optimize for. That's the intuition. So in almost every talk I give on recommender systems, I do a brief rant on how this is not an AI pure data mining or machine learning problem. And what I mean by that is that there's one really horrible reality that we have to deal with. And that is, if we think of ourselves as having a data set and covering up 10% of it or so, and building our system to optimize for recommending the 10% that we didn't tell people had already actually been consumed and liked by the customer, then we've just optimized for the most useless recommender we can come up with. The recommender that recommends things that people found on their own anyway. We don't need that. Why would we bother? We want to find the things that not only the customer didn't find on his or her own, but that she or he likes better than the ones they found on their own. Because that's our grail, is to say, if customers do just fine without us, then why are you spending all this money on fancy technology? Our goal is to discover new things, either to benefit the customer or to benefit us by giving us something to sell to the customer. And when you think of that, suddenly the idea of optimizing for missing values dries up a little bit. And we move into an era where a lot of the work we're going to have to do involves experiments. If we want to see if it works, we're going to have to deploy it and have people try it. And that's just a very different kind of world. Okay, I feel better. I'm going to go rather quickly through some of these examples, but I want to give you examples of where the research community has started making advances here. So we've talked a little bit about serendipity or about diversity. I'm going to talk about both that and serendipity. Definitions for these, hard to pin down. Diversity, typically we talk about how different are recommendations from each other, or maybe from some baseline. I might talk about a basket and say diversity is how much the things in the basket are different from each other. But I might also say diversity is how much are my recommendations different from what you've recently consumed. Because I'm trying to show you things you're not going to find on your own otherwise. Serendipity is a term which is sort of delightful. It's almost part of its definition. Serendipity is about delightful unexpectedness. And most of the definitions you'll see say, for something to be serendipitous, it has to be something you didn't expect to see, maybe you didn't know about, you didn't expect to see recommended, or you didn't expect to like, but that in fact you did like. It's not serendipity if something's unexpected and bad. But if it's unexpected and delightful, that's serendipity. And there's lots of papers out there. These are here. You can always go back to the video and see them. But what they show is what we would think about intuitively. Diversifying a list of recommendations can add value to users in real experiments with people, even when the accuracy goes down. We know this intuitively, and how much it changes by domain. This was in the domain of books. People wanted to see greater diversity. In other work that was looking specifically at music, we saw that people seek novelty differently at different times. There's been a lot of follow-on work by this. Vikas Kumar, this was sort of the anchor work of his dissertation, where he looked at when do people want the old familiar songs, and when are people more adventurous and interested in hearing new stuff that they might like. And this happened in somewhat predictable times of day, predictable in terms of the gap since they've listened recently. If you haven't been listening for a while, you tend to want to hear your old favorites, which, intuitively makes a lot of sense. We've also, as a result of this, started giving people greater control so that they can tune for this and say, I want more diversity, I want less diversity. Giving people control is one way to do it, though honestly, it's probably not the best way, because what people do is tune for a while and then stop and say, this seems right, when in fact we know their preferences change over time. And to do this right, you actually want to understand what people see. And we've done studies when you change algorithms, and we found that by and large, as much as we think novelty is our purpose, When you go to a lot of novelty, people are not that happy. They don't want things that they can't evaluate, that they have never heard of. But they do like diversity. And so figuring out what they can access, what's close enough to be comfortable without going so far that you turn people off, is an empirical problem. So we've done other work in this space looking at personality. It turns out different personality types have different preferences. I'm not going to take you through all of that work. Instead, I'm going to take you to one particular example. If you've seen most recommenders that are out there today, they're built on the concept of something like a top-end list. A list that takes you a set of recommendations. That's what happens when you type a search in Google. Here are your 10 best or your 20 best. If you go to YouTube or Netflix, here's a set of items in order. And so Chen Zhao and a team of us realized, wait a minute, there's some assumptions in that we don't necessarily like. Like, why would you show the best things in decaying order? And, you know, intuitively, if you think about it, if you're always showing the best stuff the first time and the next time and the time after that, people keep seeing the same thing. Or, in other words, come back here. Nothing has changed. Is that what we really want? I don't. There's probably something implicit here that says, I don't want to look at this for a while. At the same time, we run into the issue that if you start at the best and work your way down, you know, the things on the first page look pretty exciting. But as you keep exploring, things get pretty bad. And that might be a sort of depressing experience. I mean, imagine for the moment, I'm from Minnesota now. I've got to use an example from Prince, the late Prince. But imagine a concert where you started with Prince's greatest hits, Purple Rain, When Doves Cry, and then you got the hits that some fans know, not too popular. Go back. Oh. Excuse me a second. I knew this was happening. I just didn't know it was happening in this direction. And by the time you're here, you're at the ones where if you look these songs up, people said, we don't know why he put this on the album. People leave halfway through. Now, if you're a search engine, that's a good thing. You want to exhaust the good choices and be done. If you're presenting videos to somebody, maybe you want to mix them so that people have delightful videos all the way through. So we experimented with this idea. We tried a concept we called cycling, which demotes items that have been viewed a bunch of times to expose fresher recommendations, and serpentining, spreading the top things out across many pages. Intuitively, the way to think of cycling is, hey, if we've shown this enough times, let's move something else up. The way to think of serpentining is, instead of putting the worst items down below, let's just shuffle them so that the second best item is on page 2. Now, the results of this were complicated. I'm not going to expect you to grasp all of this at one time. But the short message of the results was, some people hated this. And some people really liked it. And the people who liked it were more engaged. The accuracy was worse. The familiarity was worse. Oops, I have another one of these pages that I'm afraid jumps on its own. But people looked at more content. They marked more content that they wanted to see. In the cycling case, they even found a higher percentage of things that they wanted to see. And they commented that there's change, there's freshness. That's a pretty neat thing. Even the serpentining case, we increased the number of things people found that they were interested in. Give you one more example. Maybe sometimes the best way to recommend is not to recommend at all, but to let people explore. So what if we wanted to do that? How could we help people explore? Well, we could take them into a system, show them some stuff, pick strategically to be fairly diverse, let them say what they like or dislike here, compute a little bit using our same data, and here's some new things. Oh, those are interesting. Let me mark the ones I want things more like and less like. Compute a little bit. Bam. And I could do this as many times as I need using the same data that an algorithm would use, but I'm going to be the learner. I'm going to be the explorer. And what's interesting about this is we asked people whether they thought this was useful. And a bunch of people thought this was pretty useful. If I want to browse or explore, about 80% of it, people thought it was useful. 50% thought it was very useful. I want to build a list of movies to see in the future or find a movie to see. They got it. They got that this isn't a way to keep informed about new releases. And it's not perfect for everything, but it's good for a lot of things. The thing that surprised us is we run a recommender. And we asked people, well, how does it compare with the existing recommender that you use? And, you know, if what you wanted was to learn about new releases or find movies to rate, things you've already found, it's not even close. But if I want to find new and eclectic things to explore new tastes or maybe find something to see with others, there was no question people preferred exploring themselves over letting the algorithm find things for them. Interesting possibility, interesting comparisons there. So I'm going to wrap this up with 2 slides, and then if you haven't already, I'm encouraging you to put in your questions. I sort of love and hate machine learning. I hate it because machine learning is so good at certain problems that frequently we solve the wrong problem really efficiently and at scale, and we stop looking for how to solve the right problem. And this happens whenever the wrong problem is easy to solve and the right problem is hard, right? It's easy to optimize to match existing data. Just throw it into a deep network and watch what comes out. It's harder to expose people to new stuff. And all too often we do the thing that's too easy. On the other hand, that power, that efficiency is really great if you can take the time to first figure out the right problem. Machine learning approaches have some inherent appeal. There's a natural structure under them that really is in some ways understandable. And if we can measure something, we can probably optimize for it and build something that will deliver whatever it is that we're measuring. So my takeaway messages are that recommender systems are not missing data problems. They're challenges in being useful. And the algorithms won't figure out the right problem to solve. That means we need a bridge. We need a bridge between people who study humans and people who study computation. Those people who study humans exist in computer science departments like Bart or like me, but also in marketing and psychology and other places. And those computation people, whether they label themselves as data mining or machine learning or AI or algorithms, we need to work together. I will argue to you that metrics are one useful bridge. If we figure out what we're trying to optimize for, people coming back, diversity, serendipity, and we set our best computation people on how to optimize eventually the combinations of those metrics that correlate well with user experience, then we're likely to come back with much more fulfilling outcomes. So thank you, and I'll be delighted to take questions.
All right. Thank you, Joe. That was a wonderful talk. let's move on to the questions and answers. The first question that I'm going to ask actually comes from the ACM Discourse Forum. And so as a reminder for everyone, that's where you can ask questions and continue the conversation even after this talk. So the question is collaborative filtering really domain-free? And my follow-up to that would be kind of, would it be possible to create a recommender that is, you know, domain agnostic, so to say?
So repeat for me is collaborative filtering really
domain-free?
Domain-free. So yes and no is probably the right answer to this, which is a beautiful answer because it doesn't help you at all. So I'll go a little bit deeper here. The concept of collaborative filtering depends on very few assumptions. The main assumption it depends on is that a user's, and in fact all users' tastes change either very slowly or in roughly similar and predictable ways. Because collaborative filtering starts with the assumption that what I liked yesterday is relevant to what I like tomorrow, and that our agreement yesterday is predictive of our agreement tomorrow, and therefore the usefulness of your data to me tomorrow. And so that assumption fits in many domains, but not all of them. There are domains where the thing you want has absolutely no consistency with past performance. It's only relevant for the next 20 minutes, and it's irrelevant after that. It's not a useful technique. But there's another assumption about the domain on which you're performing collaborative filtering. And that assumption is this assumption that agreements, that the domain is scoped so that agreement is meaningful. And people have looked at this challenge in cross-domain recommender systems, where you say, well, wait a minute, if we agree on shoes, do we also agree on shirts? Yeah, on average, probably. If we agree on shoes, does that predict that we like the same books? Not so much. And so the technique may be content agnostic, even when you use content attributes in it, but its application can never be content agnostic. You have to find domains where agreement exists, and if you want the most powerful algorithms, you have to identify the relevant attributes that should feed your systems to give them something useful. So much of today's work is on how do I put more useful information. If I'm recommending tourist activities, I probably need to be aware of the weather. It's an important context. I might need to be aware of the size of group you're traveling with. You know, it's not a bad idea to bring a group of 3 or 4 into the Louvre to see the Mona Lisa. It's a lousy idea to bring a group of 40 into that tiny space. And those sorts of things become very domain specific. So I don't believe we'll ever have just a generic agent that figures everything out until that generic agent is also understanding the domains.
Thanks for that answer. That's very clear. So the most popular recommendation algorithms nowadays are latent variable models. But what about explaining those models? Like, how do you explain the latent relationships that a recommender system uncovers?
So that's a great question. It's a question we've all struggled with. And there are 2 answers, roughly, that the field has come up with. One of them is to constrain the latent factor model. I haven't seen a lot of this, honestly, but there was some wonderful work done a bunch of years ago of saying, you know what, if we don't just factor a matrix, but if we cofactor or if we co-optimize a content space model and a collaborative model, So that you think about, you have tag descriptors for items or attribute descriptors for items at the same time that you're building a model of user item preferences. You then have content space labels that go with each of those attributes. And in theory, those could be useful explanations. It's not been tested that I know of as to how useful those explanations are. So the other approach that's happened most often is recognizing that explain is not actually what users often want. When somebody says why, they don't necessarily mean how did you come to the answer. They mean how do I decide if I should adopt your answer? So, if you were a travel agent and somebody comes in and says, hey, I'm looking for a place with a beach and not too much heat, but sunny, and your first version, oh, I've got this lovely Kazakh resort. And they say, why? The true answer is, I have no idea. I have this network of neurons in my head and it just popped out. But that's not the answer they want. They want you to reflect and say, oh, what do I have to tell you about this that might help you make your decision? Well, the average temperature is, 70 degrees Fahrenheit during the day, 60 at night. The time of year you're talking about, there's 13 hours of sun. There's gourmet food, and they have vegetarian and vegan options. But I'm not explaining my recommendation. I'm giving extra information to help somebody make a decision. And I think in many cases, that's what we actually want to do with recommender systems. It comes up with a product on the screen. It doesn't know why, but it can say, here is some honest information, ideally not trying to persuade you this is the right product, but trying to help you make the right decision for you, presenting the pros and cons of this choice. And if the cons are compelling to you, maybe helping you link off to an alternative product that doesn't have those cons.
I see. Great. Follow-up to that is the next step would be control. What are some good ways to help people kind of take more control over their recommendations so that, items that they don't want don't show up?
I think there's a lot of them. You can build systems, and many have been built, to allow people to explicitly blacklist items, right? Many of the music recommenders, particularly the streaming music sites, have a way to say, just never play that for me. And you can give people the way to put in explicit inputs, even on systems that were implicit. We could see more of that. I mean, we're seeing a little bit of that in the advertising networks where you can click and say, I never want to see this ad. That's a great thing. It's giving control over the data. But I think you can do more. You can make the profiles you have on users visible, understandable, and even editable. You can see this on some sites. If you go to Amazon and try to improve your recommendations, it shows you what it believes is the data it has on you. What have you purchased? What have you said you like? And you can go back and say, wait a minute, I did buy that, but I don't like it. Or I bought that, but it was a gift. That's not the sort of thing I want for me. And remove it from your profile, and letting people edit their profiles either permanently or as a what-if exercise to explore. So if I felt differently, what might I get instead? Can be a powerful technique. And then at the end of the day, I think there's a bunch of cases where you simply want to give people, control to steer, whether that means they get to tune the algorithms and select them. Few are going to do that much. It takes a little work. But control to steer through interfaces like I showed you that fly through the space and see things, often with neat visualizations or interesting representations, so that people can find things in their own way.
I see. Yeah. Moving to a somewhat different topic that's close to my heart. What about creating recommender systems that kind of respect people's privacy? Is there a way to build a recommender without disclosing too much information about yourself and still get good recommendations?
There are. people have developed a number of systems that either involve sort of anonymous sharing of information into a pool using concepts like k-anonymity, where we can, provably show that we can not identify certain things with certain numbers of pieces of information in a database. People have done systems that deliberately add deniability into recommenders. And people have done systems where the recommender, sits on your computer for your use and isn't connected to a marketer or a central service. I'll be honest, I think all of these solutions today require a lot of work from a user who cares. And the vast majority of users, not just in the US, where privacy to a large extent is mostly unprotected, but even in the European Union, where there's fairly strong privacy protections, most people don't care enough to do anything about it. I've spent my time in Europe, and you go to a web page and you click yes. Yeah, there's something you should read, but you don't get to the web page if you read it. You get to the web page if you click yes. And we all know that experience. And so I think if you're really serious about privacy, the things we may have to think about are, what are the permissible and impermissible uses that we're going to allow the business entities that collect this data to make of that data? And what rights do we have to inspect and change and withdraw that data? Because for the vast majority of us, we're going to take the convenient solution, even if it's a convenient solution that gives up privacy.
Makes sense. Going from privacy to kind of ethical questions, you mentioned at one point during your talk the kind of juxtaposition of recommenders as a marketing tool versus as a tool to create self-empowered consumers. What are the moral implications of building recommenders that just tell you stuff to buy? If you like this, you will also like this. What about a recommender that says, instead of this, you might also like this? What about recommenders that actually help people make better decisions? Do you think there's a market for that? And how do you think those systems would be different?
So I do believe we see a lot of that in the commercial world today, that it's not all add-on. It's a lot of, hey, you're considering this, this might be a better choice. We don't see a lot of businesses throwing up or you could buy nothing and pay down a bit of your credit card bill, and maybe they should. And I think the infrastructure has become there where these kinds of services are possible. I mean, the fact that as I go shopping, my credit card company has an app that's in my browser toolbar that can pop up and say, hey, wait a minute, you might not be getting the best deal on this. I can find it somewhere else cheaper. Means I could also engage an app that says, hey, wait a minute, this doesn't match your life goals right now. I know it's an appealing whatever it is I might want to buy there. Maybe I want a new tie or something. But you said your top priority is to save for your kid's college education, and a new tie is not getting you any closer to that, especially if it's handmade in silk. And so I think there is an opportunity for third parties and nth parties. Right now, the interesting spaces in recommender systems are two-party relationships, a seller and a buyer, or a provider and a consumer, sometimes for information, and three-party relationships, a marketplace with many sellers or providers and consumers. So Amazon is sometimes recommending things that it doesn't sell, its affiliates sell, or Google News recommends news from the Washington Post or Fox News. Yeah. I think the idea of people having personally chosen agents in that space that recommend for another objective is a really exciting thing to put in there. And I think that the ethical considerations of all of this, and I think of sort of addictive behavior in general, are ones we have to pay really close attention to. Because for most people, recommending a product is probably not an ethically questionable thing to do. For somebody who's a compulsive spender, who's in deep debt, it's an ethically questionable thing to do, especially if you know that's the case because you have all this data about somebody. And we need to start thinking about standards for our field that have the people developing these systems thinking hard about the fact that, wait a minute, we can identify when this is bad for somebody. We need to make sure that's clear.
Yeah, that makes sense. I hear there's about time for one more question, so I'm going to cheat and make it a double-barreled question. So you've given a couple of, or actually quite a few examples during your talk of kind of bad recommendations. And the double-barrel part here is that I see a lot of questions about deep learning in recommender systems and people wondering whether that's the future and maybe we can get much better recommender systems like that. So that would be the first part of the question. Do you think that that's the case? Do you think that we're on the brink of doing any better? And are there already some systems out there that are already doing very good? Or do you think that we just have a lot more to do in this space?
So I think the short answer to that is there are a lot of systems that do well today. I think most of those systems have some flaws, but largely the things that are contained in spaces can do well because the space in which they're operating is very clear. And so, you know, even the product recommendations, many of them, the product associations that say you're looking at this, here are some things that are reasonable alternatives, work pretty well today. The news portals that try to build news for your interest, they overfit a bunch, but they do a pretty good job. I spend an immense amount of effort trying to teach Google News that I want to know what is being said by both the extreme left and the extreme right, and not just the center or where my politics lies. And you have to over and over reinforce it because the things I want to read are not what I want it to present to me. Mm-hmm. And so that's going to be my answer to both questions, which is I think there's a lot out there that's good. I think there's a lot out there that works and is not just making money for businesses, but is creating services that are engaging to customers and helping them find good things. But I think that right now, most of that is overfitting towards whatever it is that I learned from you is what I'm doing for you. And I don't think deep learning today has provided any answer to that. Deep learning is an even better overfitting technique. Mm-hmm. It might improve those overfitting cases, but until we figure out a way to train it on things that can teach it that what you like is not necessarily what you do, which I think there's some hope for in other AI techniques. And there may be hope in deep learning, but it's going to require new kinds of training data to make that work. And I'll be honest, this has been a problem from the first day of recommender systems. The earliest systems in the early 90s, people were saying, do we want to go to our basest instincts and read what we like? Or do we want somebody who's more educated, more worldly than we are to recommend it to us? Do we want a critic or an expert? And I think those are questions that are going to stick around until we have systems that we're much, much happier with.
Great. Yeah, that's very well said. I could go on like this for another hour, but unfortunately this webcast has to end. So I would really like to thank you, Joe, for your really informative presentation and your insightful answers to the many questions that were being asked. Also, a special thanks to each of you who's listening for taking the time to attend and participate today. This talk, as I said in the beginning, was recorded and will be available online in a few days at learning.acm.org. You can find announcements on upcoming talks and other ACM activities at learning.acm.org and on acm.org. Also, please fill out the quick survey that you can see on your screen right now, where you can suggest future topics or speakers. On behalf of ACM, Joe Konstan, and myself, Bart Knijnenburg, I would really like to thank you for joining us, and I hope you will join us again in the future. This concludes the talk. Thank you all for attending.